Hello and welcome to this Mekoprint webinar. There are many words for the interface between human and machine. HMI, user interface, keypad, operator panel, control panel, in German Tastatur oder Eingabesysteme, you name it. In this webinar, we might use them all. This webinar targets R&D engineers working with mechanics and electronics, technical project managers, purchasing and industrial design experts working with the physical part of the user interface, the part that you touch and feel with your fingers. My name is Dominic Nielsen. I am Business Development Manager at Mekoprint.
And my name is Thomas Lenner, and I'm a design and project engineer here at Mekoprint. And together, we have the pleasure of guiding you through the world of keypad development. So take it away, Dominic. I'll see you later.
See you later, Thomas. So why this webinar? What is our motivation to share some best practices and how-to with you? We work with physical HMI solutions, meaning the electromechanical interface between human and machine every day. It is a vital part of a product's look and feel, about the product's quality perception and the success in the market. We also see that the focus on the keypad sometimes comes rather late in a development project, when mechanical or electronic concepts are already made. This might lead to design compromises, extra iterations, eventually extra cost, and even delays in an R&D project. For many R&D teams, the user interface is not a specialty and not a core competence, since you not often touch it. So sometimes it can be difficult to create and develop a keypad in your team. The goal of this webinar is to demystify and simplify the task of creating a good user experience. On average, in our team, we do 10 user interface projects a month. We work with many different products, many different brands, many different industries, countries, and different types of use cases. Today, we want to share our best practice with you so your job gets a bit easier next time you have to do a user interface. Let's have a short look at the agenda for this webinar. During the webinar, we will offer some key takeaways and provide some specific examples for you to relate to. We will start with a 3-minute introduction of Mekoprint, the user interface team, and the Mekoprint group. And then we will spend most of the time talking about elements that make up a good keypad. A case story will then exemplify the situational briefing, the building blocks, and the development process. And finally, at the end, you will have the opportunity to ask us questions. We will answer questions that has been sent in before the webinar or during the webinar. For more than 40 years, the user interface team has helped customers creating their user interfaces. We have a solid and structured process to do that. We have a team of technical experts, and we can help you in all phases of the development. The Mekoprint HMI team is a part of a big group. We call it the Mekoprint group. So you can use the Mekoprint user interface team for a close collaboration in the design and engineering phase. We have teams in Denmark and in Hong Kong that can help you in a very close collaboration in this very intensive phase. We can help you with the manufacturing of your user interface. Mekoprint has a global production setup. And finally, we can support you in assembly questions and technical integration questions, because the user interface often is a part of something bigger. There is a Mekoprint user interface in many global brands. Here are some examples for you. As mentioned before, the user interface team is part of a big group. There are 4 different business units helping our customers with different types of technologies. On top of that, there's a global network of partners and sub-suppliers that we can use to create your user interface. Our customers perceive Mekoprint as being a reliable and proactive business partner that has a dedicated collaborative approach and a unique broad technology palette and experienced tech experts. All we do in Mekoprint is 100% tailor-made for customer solutions. Another topic that occupies us a lot in the collaboration is sustainability. But back to the main topic. So, what makes up a good user experience through a user interface? We want to share our passion about HMI and user experience with you. The following model is our view on key elements that make up a great keypad. Let me give you an example from another word. Recently, I celebrated my 50 years birthday. I had to consider about the topic of the party, the people, the food, the schedule, you name it. I also had to consider if I have a lot of experience in planning and making a party, or if I want to have some external help. If I want outside support, I need to describe what I want and what I don't want. And I might need to describe my ideas, my budget, my schedule. Why making this example? Because you can transfer it to many R&D projects, and especially to the topic of user interface. Usually, engineers, product owners, and project people know a lot about the use case, the pros and cons of the product, the current generation's strengths and weaknesses, the user, the competition, all that part that relates to the use situation. That's what we call the situational briefing. The next important thing is the keypad building blocks, the ingredients, if you want. The knowledge about keypad technology differs a lot from team to team, from company to company, and from people to people. Some of you might have a long experience in creating user interfaces. For others, this might be the first time. In some cases, you will draft a first solution yourself and share it with an external partner. In other cases, you might choose to make a specification and requirement list and ask an external partner for concepts and solutions. The third part is the specialist competences. It has a bit to do with knowing the keypad building blocks, the pros and cons, but mostly it has to do with crafting the right solution and combining all the ingredients and the building blocks into a solution that works for the use case, that works for the requirements, that works for the cost, and many other parameters. We will now look deeper into the 3 areas. Thomas will now talk you through the situational briefing and the keypad building blocks, and I will later give you a short overview about the HMI specialist competences that you can use at Mekoprint.
Thank you, Dominic. As Dominic mentioned, one of the areas that makes up a good keypad is a so-called situational briefing. And now I'm going to talk about some of the areas to consider and the questions to ask yourself when creating this situational briefing. Your situational briefing sets the framework. We believe a good briefing and definition is the basis for choosing the right solution for your keypad. For example, here at Mekoprint, we start every project with a discovery phase and a situational briefing together with our customer. Some of the areas in the situational briefing can be the end-use environment. For example, where is the keypad going to be used? What works in an agricultural machine doesn't work in a lab. A product submerged underwater needs another construction than a product that's used indoor and occasionally wiped with a cloth. But also, who is the end user who is going to use this keypad? Are they wearing gloves? Can they see the buttons when they're pushing them? And also the cost. It can be important with a target cost for a keypad. It might limit certain solutions due to a low cost. It's important for us to understand this, to choose the right design direction from the start. But also sustainability, where we look at, for example, choice of sustainable materials, design for recycling, solutions that's easy to disassemble. We might also look at minimizing the amount of LEDs for backlight application to reduce the power consumption. This is an aspect that's considered more and more in the design phase. Might also be part of a strategy, a new product strategy. Maybe you want it to look more high-end as part of a design line, or simply you just want to improve the UX. And last but not least, your timeline. What are your planned deadlines for design freeze, prototyping, and series production? All something that's needed for us to do a project plan and deliver in time for you. So to sum up some of the key takeaways from the situational briefing, you have to ask the right questions yourself as early as possible. If possible, make clear prioritizations of your parameters, or simply just involve an HMI specialist for support. So the second area to look at when creating a keypad is what we call the keypad building blocks. We see a keypad consisting of 6 main layers. You see, we have a front layer, we have a light layer with a click layer, and also the electrical connection onto the electrical layer. We also look at the mechanical integration as part of the whole stack-up. Now I'm going to take you through some of the key considerations and possibilities within each of these layers. The front layer, that's where functionality and creativity meets for an optimal UX. First, we can look at some of the functional properties of the front layer. It can either be a requirement for UV resistance, maybe it has to be anti-static, maybe antibacterial surface coating is needed. Could also be that you have certain requirements for the flammability. And the front layer also is the layer where you have the possibility to be creative with different visual effects. You can either choose different materials to enhance the visual effects. You can play with contrasts between gloss and matte surfaces. You can also use shapes and cavities to highlight certain areas of the keypad. And last but not least, use colors to optimize your UX. Now, let's have a closer look at some examples of how to do this. When looking at the front layer, we have 3 main material types used for the keypad. We have foils and films, which primarily is polyester and polycarbonate. We have a silicone rubber. And we have plate materials, which normally are materials thicker than 1 millimeter and rigid. These can be PMMA, or also known as plexiglass, be it polycarbonate, but also polyester. When it comes to foils and films, the key advantages is that it has a slim, flat design, and you have the possibility to add artwork and graphics and play with these contrasts between gloss and matte. It also has a seamless design, which makes it easy to, for example, clean by wiping it off with a cloth. Silicone rubber is a very robust solution, and it has a very good tactile feedback when combined with a metal dome. Silicone materials are also very good for diffusion of light if the keypad is backlit. Compared to foils, silicone has the advantage of being able to play with level design, so doing curved surfaces or raising the height of a key or other areas to highlight them. Silicone is more limited when it comes to the implementation of a lot of colors and artwork as the possibility for foils. When it comes to the plates, these are normally used for so-called industrial touch, where a plate is combined with touch foil, which has the advantage of being a very robust touchscreen with a seamless and clean appearance. Gloss contrast is a good way to highlight buttons or important interaction areas. Here's an example where you can see the buttons are high gloss here, and the surrounding surface is matte. When it comes to colors, screen printing colors on foils and films have endless possibilities. And even using digital printing like this for photorealistic graphics and graphics with gradients can be printed. Due to it's flat in the printing process, almost everything can be printed. For applying colors on silicone, this can also be done with screen printing, but due to its often level design, it is more limited what type of graphics can be added. Co-molding for adding colors is also a possibility, where two different colored silicones are molded together. Shapes and level design in your keypad is also a way to enhance areas of the keypad, especially in situations where the keypad is operated with gloves or without direct eye contact. This can be useful. That's where tactility through level design of the buttons can give a great UX. And that's where silicone rubber has its strength compared to other keypad materials. And here's a good example of a concave keys, which makes it easier for the user to locate them if they cannot see them when pushing the buttons. Here's another example of how far you can go with the level design. Keys here are heightened, and the area for the symbols is recessed, creating a clear segregation between the two. And this also shows an example of one of the strengths for silicone keypad, namely the integration of light, which I'll come back to. And again, yet another example of how you can use the level design possibilities on the silicone keypad. Here we are using clear split lines between the keys and creating these recesses around the navigation key here to make a clear segregation and divide them. And here's an example of a silicone keypad where there's a smooth transition between the keys, but still there's a clear segregation through it by using this level design, but also adding colors. It's also possible to combine silicone keypad with either a front foil or a plate material. This is a good combination because it gives you the graphic advantage of the foil, where, as mentioned, you can add almost limited colors and graphics, and you have the good tactile feedback from the silicone key. We also see the use of the so-called dead front effect, which can be used on both films, foils, silicone, and plates. This is where a symbol is hidden until it's lit up, like the symbols in your car panel. It's only showing the graphics when it's backlit, and therefore only indicating the relevant status to the user when needed. So to give you some of the main key takeaways about the front layers, I would say that you should use foil keypads if you look for slim design and graphic design options. You should choose silicone rubber as a keypad material for outdoor and rugged environments, and for integration of backlight or using this so-called level design. And the plate materials are ideal for these touch-like displays with a simplistic design and a high robustness. And you have to remember to consider these material combinations for creating contrast, and clear interaction point, and enhancing the UX of your keypad. One of the other keypad building blocks is the click layer. And this layer defines the feeling of the keypad and indicates when the key has been pressed. And some of the elements you can consider here is who is the end user? How are they going to use it? How are they going to interact with it? So setting a specification for how should the tactile feedback be? Is it allowed to make any sound, any audio feedback when you press it? What should the activation force be? How much force should you apply to it before it actually activates? What is the snap force that indicates when you actually push the button? And the lifespan of the key. How many times is it going to be used? And the most common way to make a tactile click is with a metal dome. It comes in a lot of variants with different sizes, shapes, and actuation forces, and are cheap to implement into a keypad. A metal dome needs a so-called dome coverlay, which is a stack-up of adhesives and spacer materials to retain and stick the metal dome to an array onto a circuit layer. Tactile switches can also be used to create a click, but the selection is a bit smaller. Tactile switches are normally used when you have a PCB with soldered components, where the tactile switch is also soldered onto the PCB in the same process. Or if you have very limited space on the circuit layer, a small tactile switch will give a better click than a very small metal dome. It's also possible to achieve a tactile feedback in the silicon itself by designing the shape of the keypad so it snaps when it's pushed. This is normally done in connection with a carbon pill underneath the key to connect onto a circuitry. This solution is usually seen in situations where there are no requirements for a so-called hard click, but is also a good example of a more sustainable construction where you have fewer layers and no metal domes. Another building block is the light layer. And the light can give extra life to your design or help the user operate your device safely. And some of the things you can consider here when using light is to avoid hotspots. You want the light to be evenly distributed in your symbol. You might have to use light blocks so you don't have light going from one icon to another. You also have to consider the function of the light. Is it for status? Is it a backlight for nighttime operation? And also consider the keypad material versus the light. If you have a lot of light, it might be better to use a silicon keypad than a foil, or the other way around. Here we can also look at the distance versus the light guides and diffusers, meaning that you have to consider if you don't have enough distance, you might have to implement light guides or diffusers. So let me show you some examples of how different types of light can be used. One way to use the light is for something decorative. And here is an example of where the colors have been printed with a light where you have a white LED underneath and it light up in a certain color. And here you also see that we have used the dead front effect where the symbols are hidden and only visible when they're backlit. It could also be functional light to indicate the status of a function or an interaction. This is normally done via a small status window or a backlight symbol like shown here. Or it could just simply be backlight, to backlight all of the keys for use during nighttime operation by the user, to enable them to actually see the keys they have to push. You can easily get carried away when adding light to your design, but remember the amount of LEDs can have a huge effect on the cost of the keypad. And in some cases, less light can actually be more. When it comes to choosing the electrical layer, both the environment, electrical and mechanical design concepts can affect the choice. Polyester with printed silver is the most commonly used electrical layer for a keypad, as it is cost effective, but it also has a limitation. When it comes to how much you can bend the silver traces, normally we do not recommend to bend the silver tail more than a radius of a pencil. PET also has its limitations when it comes to moist environments. So it is important to weigh the pros and cons for your specific project. FPC, on the other hand, is a copper-based foil and is very good for use in exposed environments, and the traces are more flexible, which makes it more resistant to bends and flexes. It's also possible to solder components onto FPC due to its captain carrier and copper with high heat resistance. Copper is also more conductive than silver, which is useful if many LEDs are used to ensure a common lighting of the LEDs. PCBs has the same functional features as FPC, but is normally chosen if there are requirements for the stiffness of the keypad in connection with the mechanical integration. But also if there are many soldered components on the PCB, this might be the way to go. So to sum up, to find the right click, the end user and the use case needs to be defined. Optimal light, well, that's the sum of function, materials, and design. And as mentioned, less light can be more in some cases. The electrical layer is primarily defined by the use environment and the mechanical and electrical integration. When it comes to the electrical connection, it is important for us to understand the interface between the keypad and your PCB. Also, the environmental condition it is exposed to might point in a certain direction for choice of electrical connection. You might want to consider these elements like vibrations. Is it during use exposed to a lot of vibration? How will it be assembled? What is the direction of the assembly and how will you connect the tail? The distance from the PCB to the keypad, so how long should the tail be? Is it going to be disassembled? Do you need to consider how you should disassemble the tail from your PCB? The most commonly and cost-effective interface between a keypad and a customer PCB is a tail made to integrate with a SIF connector, like shown here. And if, as mentioned, you have vibrations, you might need to fixate the tail more, and then we can either add a connector like this, which also eases the assembly process, and you can have this with a lock, which actually locks it when you connect it, so you ensure it stays in place during use. And when it comes to mechanical integration, there's a lot of questions that needs to be answered here. The details around mechanical integration have a huge impact on the keypad solution. So even though it comes last here, it's actually something we need to ask as the first question. But let's just keep it here as the last point. So the first thing you can ask yourself is, how is the keypad going to be fixed? Are you going to use adhesive? Do you need screws? Is it press mounted or something else? And when it comes to the adhesive, it's very important with the assembly surface. It's important to have this spec early to choose the right adhesive material. And that's a huge area with adhesives, so that could have a whole separate seminar for itself. And also looking at the simple surface, what type of material are we going to fixate it onto? Is it curved? Is it flat? Is it structured or smooth? You need a different adhesive for low surface energy plastics and another for high surface energy metals. There are a lot of questions to consider here. Also the assembly direction. Is it done from the front side? From the back side? Are you sliding it in? So many possibilities. So yeah, again, there are a lot of questions and considerations in finding the right keypad solution for mechanical integration into your assembly. But here it's important for us to understand the assembly process and the sequence and all of the other questions. So to sum up, there's endless possibilities to combine the different building blocks. The essential task is to select just the right elements based on your situational briefing. And that's also why many of our customers involve us in the entire development phase to make sure that the keypad is designed correctly. And my colleague Dominique is going to tell more about how we approach the development process.
Thomas has provided an overview of situational briefing and building blocks. Let's now talk about the third part, the specialist competences. And back to my party example. Once I decided to hold my 50 years birthday at home, I found out that I need a catering expert. I started to search for an expert that had a proven track record. I I had my own ideas to share, but I also expected the expert to ask me some additional questions. So with your user interface, once you have decided to use an external expert to help you with the user interface, you ask yourself the question, where in the development process is your user interface project and which parts of the development you want an expert to help. It is in our nature to ask the questions that you don't provide. We have a robust and well-defined model to bring if you want us to help with your user interface. The following model can help you define your current position and the steps ahead. A more comprehensive overview of Mekoprint's development and engineering services can be requested at the end of the webinar. Projects and people are different, so our services. Similar to a taxi ride, you can hop on and off as often as you like, and depending on the knowledge and resource situation in your team. Tap in where you need our help. You can stop after development, or you can have the full solution from concept to the final solution. Ideally, we take the whole journey together. Sometimes we are involved in the middle, and that's totally fine. The important thing is to get a good start and a good discovery, or what Thomas earlier called the situational briefing. It is important that we ask ourselves the right question. Target price, decisions already done, etc. I will now give you 3 typical scenarios of a cooperation. Here is a scenario what I would like to call design review. This means you come to us with a solution proposal, a drawing, a concept that you already have found yourself, and ask us to do a maturation of this design. Sometimes we also call it manufacturing feasibility, but it is more like based on a concept that you already provide. So this means here you provide us a drawing or 3D model or some specification and ask us for a review. We will go back to the step which is then called discovery, because we will ask all the questions that we need to have the complete overview. And then, depending a little bit on your knowledge and the solution you found yourself, we can directly go into engineering and design for manufacturing. But sometimes it also can happen, and this is shown here with the dotted line. It can happen that we do a step back and looking at other design proposals and other alternative designs, so you get a better decision base before you move forward. The second scenario is a more strategic scenario, which could be a modular concept for several HMI. This means you might have a product line that shares some typical HMI components, and you want to have it streamlined across different products. So here it makes sense to, of course, again start with the discovery and the situational briefing, but then you more or less, like the animation shows, you have the complete process from ideation of different concepts, design, early prototypes, engineering, and release for production. Last but not least, the third scenario is what we call re-engineering. Typically, this is a product out in the market which has some problems. Could be end-of-life issues, but could also quality issues. And you want to ask an external expert to do a review of the current design in order to make improvements or change of materials. So here, again, we will most likely have a situational briefing to understand the product's use case, all what has Thomas talked about, and we then will most likely do some parts of the design and engineering process depending on how big the changes are. So it can be a very small change, can also be a bigger change, making it necessary to go through the complete entire process. Let me summarize the HMI specialist competences. First of all, evaluate your own competences and your resource situation. Make sure you have access to the latest material and design insights. And if you feel that you need the help of an external expert, use the taxi. Hop on and off as you like. Finally, do a make or buy decision in your team. Now, I will hand over again to Thomas.
Thank you, Dominique. Yes, I'm going to talk about a case for a customer called BioServo. We had a close collaboration with BioServo in the development of a keypad for their innovative new product called Carbon Hand. Carbon Hand is a glove that assists people with impaired hand function. It's grip strengthened glove with pressure sensors in the finger that senses when the user needs support. The pressure sensor detects when the user initiates a hand grip, and the glove then applies the power needed to ensure a firm grip. And some of the main requirements from the customer was that it had to be washable and it had to be wearable. And we had to deliver a complete HMI solution ready to be stitched onto a textile glove. We must say we are proud to be part of this project, as it's a project or product that makes a difference for many people and improves their life quality. So here's the situational briefing from the customer. As mentioned, everything had to be bendable. Usually we deliver a keypad designed for flat surfaces. In this keypad, everything had to be bendable. The keys, the circuitry layer, everything. It also had to be watertight, as it had to be washable. The glove is used in everyday activities and had to be washed from time to time. So the keypad had to be designed to withstand washing at 40 degrees. It also had to be highly intuitive controlling. So the controls had to be easy to decode. And this was achieved by using clear colors, lights, and light rings. It also had to be integratable with the textile glove. We had very limited space for the keypad, and the keypad also had to be designed so it could be stitched onto the glove. So let's look at how we found the right building blocks for this product. As mentioned, again, it had to be bendable. Normally, we do it as a rigid keypad here to support the keys, but as it had to be bended, it needed to look at something different. And this was a new concept that we never tested before. It was not rigid. It was not a pre-bended solution. It was a rigid flex, a bendable, fully flexible circuit where we have the flexibility where needed, but also the support underneath the buttons where you have to click it. As mentioned, very limited space, a very small keypad. We also had to figure out how we can do a good click on such a small space. And as mentioned earlier, when you have limited space, we might not use metal domes. So we had to use tactile switches because a tactile switch gives a better click than a small metal dome. We also had to place the LEDs and the light blocks optimally to maximize the illumination. And here you can see what happens when you don't do design features where you get a common lighting. You get these so-called hotspots. And here you can see the development until we achieved a nice solution by using another silicon material, but also placing the LEDs so we're avoiding these hotspots. We also had to look at the wiring. It had to be a watertight assembly. So here for the electrical connection, we used a soldered cable. It's a long flexible cable that needed to withstand pull because it was going along the arm and needed to withstand the force being applied here when using the glove. It also had to be watertight, and we achieved that by gluing the two silicone parts together, a silicone part with the PCB and an extra silicone here to seal it around the edge. And you can see here, the cable connection that is soldered onto the PCB is also sealed by using a potting. For this project for BioServer, we have applied our HMI development process from ideation to release for production. So from the ideation phase where we did concepts for this flexible circuit, to the design phase where we looked at the button layout, the icon design, and also did the test specifications to verify the design. We also helped during the prototype phase to do testing and evaluation of the designs. Especially for the bendability, we helped set up test standards and test specifications to ensure that it actually was as flexible as needed. And this was all done in an iterative process, so testing back to concept and doing this back and forth. We also, for the release for production, finalized the circuit layout and matured the construction for production, and we prepared all of the tooling. And last but not least, we also did the documentation and the compliance and the delivery setup for the customer, and ending up with a final solution looking like this. Fully bendable, good tactile click, ready to be stitched onto the product called Carbon Hand.
Thank you, Thomas, for this interesting case from BioServer.
You're welcome.
We hope you enjoyed this webinar and the case from BioServer because it combined all the elements that makes up a good keypad solution. Now it's time for question and answers. We will answer questions that you submitted before the webinar, during the webinar, or you have the opportunity to ask questions now. Thank you for joining, and thank you for attending this webinar from Mekoprint.
Thank you.
So now it's time to answer questions. We already got some questions before the webinar, but please also use the chat function to ask your questions so we can answer them now. Eventually, unanswered questions we will answer after the webinar. Also, we would like to know, because Thomas told several times that this could actually be a topic of a complete entire single webinar. So if there are any topics that you would like to have a webinar on or are interested further, also use the chat function to not just ask questions, but also make proposals of which topics could be interesting for you to get more knowledge on. So yeah, so let me just check some of the questions that we got in here. There's a question, are there any bigger buttons for more than one finger or buttons that have good ergonomics to press for a long time? A very good question, actually, because I think, Thomas, most of the buttons that we have are made for a thumb finger or for the index finger, but sometimes you need to press with your hand or with your wrist, whatever. So what do you think?
Yeah, again, it depends on what a big button is, right? So, but normally we can say that it's, as Dominique mentions, the keys are made for pushing with an index finger, but it might be for an emergency button that you want to, push it with 4 fingers to ensure that it's being pressed. But normally the largest metal domes we use are these with a diameter of 25 millimeters. These are the biggest ones, but as mentioned, also the bigger the metal dome will be, the higher activation force. So this actually has 2 kilos activation force, but that might be relevant for if it's for emergency button. That's for a keypad, but for a rubber a rubber key. If it's for a silicon keypad, you have a bit more possibilities to do an elongated key where you can support it underneath, maybe to actually do a base in the silicon design underneath to support it. So you get a feeling that it's an even distribution of the force you're applying, but the activation point underneath could be one or more carbon pills directly onto a PCB. So that could also be a way to go. So yeah, there's definitely
stiffener at the backside.
Also that,
maybe especially with carbon, we have with silicon rubber, we have the opportunity to have a stiffener on the front side, right?
Exactly,
so
on the top you can
making a cap design on top of the key.
Yes.
So yeah, okay, good. So very good question. Another question here, which could be interesting for the audience, for all of you in the audience. I'm very interested in backlighted keypad solutions. I think we covered. You had your special.
Some examples of different ways to use light
of the backlighting, but I think for backlighting we could make an entire webinar itself. So I think if you, Norbert, asking this question has some more deeper interest, maybe it's better to have a direct a chat on that after the webinar, or make a session about that. But in general, we see that backlighting is a topic getting more and more importance, especially for premium brands, because light is something, a premium feature often, beside the functional part, of course. But also, light supports a premium look and feel. So this is getting more and more important, and we have, I don't know, I think half of the projects we are doing are involving some backlighting topics. So yeah. So another question here from Peter. We need ESD protection due to ATEX requirements. Have you overlay that can overcome this requirement, Thomas? Maybe a question.
Yeah, definitely. Yeah, we are very familiar with this requirement, especially within the oil and gas industry, where it's a critical safety feature not to have the top layer of the overlay to be anti-static and in worst case creating a spark, and that's not good if you're in an environment with gas.
Explosive,
yeah. So in an explosive environment, so there are certain types of foil materials we can use that has this anti-static coating on the top. So it's very dependent on the size of the area. If it's critical regarding ATEX. If you have a very large surface, the larger the surface, the bigger the risk of generating a spark from static electricity. But it's both possible for foil, but also possible for a silicon keypad. We also managed to do a anti-static PU coating for coating silicon keypads, which is also not easy, but something we also have accomplished.
Yeah, good. So there's a question from. Let me check. There's a question from Christian. When is it a good idea to use metal dome? I understood the tactile switches have a lower activation time. The pros and cons, Thomas?
Yeah, again, it's. I think we also briefly covered it. It's very dependent on what type of circuit layer you're using, or type of circuitry layer concept. As mentioned, on the tactile switches are normally used when you have a printed silver on a polyester, which is easier to implement if you also want the slim design. The tactile switches, again, needs to be soldered onto a PCB or an FPC. So it's as mentioned, if you have a soldering process, you might look at implementing tactile switches instead of metal domes. So it's more from that sense. It might also be that it's something that you're familiar with, that you have a tactile switch and this is something that the user thinks makes a good tactile feedback. So it's used based on experience. But again, it's also something I think we can get back to and have a discussion about afterwards, because there's a lot of aspects here to do the pros and cons for these two.
Yeah, and maybe also to add from my side, it's also a little bit subjective because the clicks in a tactile switch and in a metal dome are a little bit different, and then depending on the top material you have, like silicone rubber or foil, so it's also a little bit let's say a subjective choice and what you like. So yeah, beside the cost aspects and the functional aspects. So there is a question here from Christian. You said the material of the front or first layer could be silicone or polycarbonate. Can it also be glass? Good question. Because glass, we usually a normal HMI solution is also a touch screen, which has glass. So Thomas, what do you think about using glass instead of polycarbonate or a plate material?
Yeah, definitely. We also have projects where glass is being used, but again, it's also very related to cost, because it's glass. It has to be. You can't, for example, laser cut glass, or you're not. It's also more challenging to get colors to stick to glass. When we're using glass in connection with an industrial touch solution, there's also the risk of the glass breaking if it's being exposed to any mechanical stress. Then it has to be laminated glass, a chemically hardened glass, and that's all something that increases the cost. But definitely the chemical resistance of glass, as here or mentioned in the question, is something that's better than some of the plate materials. But most plate materials also have coatings on the front side, which makes them more resistant to acids and other chemicals. So there's a huge range of different coated plate materials like polycarbonate or PMMA that can be used. So I think we also could find something that's at the level with glass, where this could be used also as an alternative to glass.
Yeah, good. So then there's a question from Teddy. Do you have solutions for buttons for safety critical applications? And I think Teddy means that there are in some industry and branches, there is the requirement that button has a redundancy. So it means maybe, for example, you get two signals out of, also you click once or you push once, but you get two, let's say, signals out of it, or a kind of toggle signal. So yes, this is something we definitely work with a lot, actually, because we have, as you have seen, many industrial customers, and there are different solutions for that. Double domes, different. You mentioned the solution with the carbon pills, so you make some specific implementations in the software to read out the signals in a safety requirement context.
So, I think we covered that question.
You covered that all. Good. Perfect. Good. And there is a question more from. Let me check. What UX design do you recommend using when the user should select a value in a range like 1 to 100? Just having up and down might take too long time to reach your value.
I have to understand which value range are we talking here?
1 to 100.
Like evaluating the UX in a range from 1 to 100? Is that the question? No.
Yeah, I think having up and down.
Maybe
I think that's a question we need to answer after the webinar, because maybe this we will have some questions back exactly what you would like to know. There's another question: which direction would you head in the design process if there are no extreme environmental requirements, but cost is a very important parameter? I think you covered that in your situational briefing, Thomas.
Definitely go for the as mentioned, the silver printed on a polyester is the most cost-effective and most commonly used way to go. But again, it also has the limitation when it's like moist environments, or it's the tail is being bended in connection with the assembly process. So so definitely that would be what we recommend if there's no extreme environments here. Yeah. But again, that's not only the environment, as mentioned in the situational briefing, there can be a lot of other parameters, the end user and the assembly process and everything else, where it's not only the environment that concludes the keypad solution.
But sometimes, actually, I think, Thomas, it's also many functional requirements and high premium solutions and so on have their way of approaching a project. But if the cost is very clear, a top parameter from the beginning, then it's also very often that we start from a totally different basis, because then you have a target cost, or you have a cost being, let's say, the driving factor. And then you much quicker sort out a lot of solutions. Maybe you touch them quickly, and we tell you why we have not put them as a candidate. And sometimes actually those projects are then even more important to look, let's say, wider on your assembly process, not only on the part, but understand the complete entire solution and the following process at your side, because it's not only the cost of the keypad, but the entire total cost of ownership. So yeah, there's a question more. It was mentioned PU coating. How do you ensure that this coating will withstand all environmental conditions over its lifetime, UV, sunlight, rain, cold, heat?
Yeah, we can also support in these environmental testing if that's needed. For some projects, we have also help with doing either the test specifications or carrying out some of the tests to ensure that it withstands the requirements, for example, UV and sunlight. But as mentioned, this is something, what are the requirements for UV? Is it direct sunlight all the time? Or so again, based on the situational briefing, specifying this is very important, so we can ensure if it's something we already know from previous projects, we can say, yes, we know that it can withstand this, or experience from products already in the market. But if it's a very specific and unknown requirement for the UV or amount of hours, then we might have to have a dialogue about how to ensure this, and maybe doing UV testing. But that's also the possibility to do testing on all of the parameters mentioned here.
And I think there's a big difference between coating that is already applied on, for example, a foil material from the manufacturer, versus applying a coating on silicone rubber, because silicone rubber itself is very, how should I say, UV resistant. So it doesn't need a coating for that. The coating usually is protecting it against chemicals, or protecting the artwork from being abrasion, stuff like that. So it's difficult to answer that question overall. So again, this could be making the outdoor requirements work could be a separate topic for a webinar. How do you solve the problem when the metal domes are about 6 to 10 millimeters from the rubber button because of mechanical restrictions? So I understand it that there's a certain difference, most likely in height. This is quite a long distance, I think 6 to 10 millimeters, but I think we often cover that because of the design freedom you have in silicone rubber, and so you can actually make actuators going inside the housing and cover this distance actually.
The actuation, the pin underneath is not shown here, but we can, in silicone, you can design so you can adjust the height of this. The focus here is not to make too long an actuation pin because of the stability. So normally we can use the size of the key and then do the space underneath, so you have an even distribution of the force, and only make the actuation pin in the silicone smaller to activate directly on top of the middle of the metal dome, because that's also very important that you activate it on the top point here to make it click.
There are so many questions, but as promised, we will answer them also after the presentation. Many very let's say general questions that could be interesting for many of you, and others very specific. But I think if I look at time, time is over. So for now, let's finish for today. We will answer questions. At the end, I would like to use the opportunity to show you some of the opportunities you have when you got inspiration during this webinar. First of all, we have this lookbook for you. There is a lot of what has been talked about today, which is light, contrast, all the elements. I do recommend that this is something you have as a paper copy at your place and you order it. You can also get it as a PDF. But my recommendation is to have it physically because it's a good enabler for internal discussions. You can have it, you can put it on the table, and you have internal discussions with product management, with design people, with engineers, and so on. So this is something you could go for. There has been many samples and pictures today. Some of them we can share to you also. So you can also order samples. As with the lookbook, it's good to have them physically at your place. You can use them for discussions. You can get a look and feel perception. And if you have the lookbook and the keypad samples are especially good if you don't have a project right now. You can keep them and use them for later. But if you have a project right now and some important topics to clarify right now, there's also the opportunity to reach out. We can have a free of charge chat and a meeting if you like. And finally, I would like to ask you if you found this webinar very interesting. You can share the link to it after the webinar to your colleagues that might be interested as well. So please remember that option too. We would be happy if you can recommend Mekoprint or this webinar to your colleagues. So thanks for now.
Thank you very much.
Hope you enjoyed. Have a nice day out there, and maybe see you soon.